Okay, we've got this piece of tin. We're going to fold it to create kind of a trapezoidal shape. The piece of tin is 24 centimeters wide. We're going to choose in this situation for it to have a base of 10, a base of 10. The sides are each 7 by 7, which makes up that total of 24. Agreed? So the question is, what angle should we fold that at in order to maximize the amount of water that the gutter can hold? So what's driving the problem is that we want to maximize this amount of water. Would you agree we want to maximize the area of that shape? What is that shape? A trapezoid. What's the area of a trapezoid? 1/2 times the height times the sum of the bases. 1/2 times the height times the sum of the bases. Now here's what makes the problem slightly challenging. We know that the area is equal to 1/2 times the height times our first base here is 10. That doesn't ever change, does it? We've said that's going to be 10. We don't really know what the second base is yet, do we? That top thing that's going to be up here. Now, obviously, we're not going to have, 10 up there, but that distance represents our second base. Well, let's try to figure that out. I've got two different variables, don't I? I should get rid of one of them. And furthermore, I don't really want H or B. I would like to have theta, wouldn't I? How about we do some trig? We're going to keep it super basic in terms of trigonometry right now. I'm going to call this X, and I'm going to call this Y. Can somebody give me a trigonometric expression that involves theta? We'll say theta is going to be that 90 or that angle right here. Okay, that angle of the triangle, we'll call that theta instead of the whole part there. Okay, can somebody give me a trig expression that involves theta and 7 and y? Sine of theta is y over 7. If I multiply both sides by 7, I have 7 sine of theta is equal to y. Okay with that? Good. Can somebody give me a trigonometric expression that deals with x and 7 and theta? The cosine of theta is equal to what? X over 7, or 7 cosine of theta is equal to x. So in this expression right here, what does x represent? That's the height. So the area is equal to 1/2 times the height, which is 7 cosine of theta, times 10 plus, we have this top base up here. What is this y value? 7 sine of theta. What is this middle value here? 10. What is this value over there? 7 sine of theta. Did we get rid of the two variables? What is now the variable that we have? It's theta. So my expression, area equals 1/2 times 7 cosine of theta. If I combine like terms, what do I get? 20 plus 14 sine of theta. Good. Now, this brings up to kind of Rachel's question earlier. in some problems, I just multiply both sides by 2, and I'm able to get that go away. Can I get rid of the 1/2 somehow here? Yeah, if I just multiply 20 and 14 by 1/2, that will take care of it, right? So area is now equal to 7 cosine of theta times 10 plus 7 sine of theta. Could even distribute that. Area is equal to 70 cosine of theta plus 49 sine of theta. Cosine of theta. That's an expression that tells me the area. What do I want to do with the area? Maximize it. How do you maximize something? Take the derivative and set it equal to 0. So derivative equal to 0. What's the derivative of 70 cosine of theta? Negative 70 sine of theta. Uh-oh, how do I take the derivative of 49 sine times cosine? Product rule. What's the derivative of 49 sine? 49 cosine. So you have 49 cosine squared, because you're going to multiply by cosine. What's the derivative of cosine? Negative sine times the 49 sine would be negative 49 sine squared of theta. Hey, we're making some progress. I remember in trigonometry, don't remember much, but I do remember in trigonometry when I had the sine, the cosine, and the sine, like I had to get rid of one of those. Do you think we get rid of the sine or the cosine? Which one do you think we get rid of? We get rid of the cosine because we have 2 other sines here. I wish that there was something I could substitute in for cosine squared. Wish somebody had told me. 1 minus sine squared. Good. So now we have negative 7 sine of theta. 70, thank you. Wow. Plus 49 minus 49 sine squared minus 49 sine squared is all equal to 0. It looks bad, but really not. You have some terms you can join together. We're almost done. What can you combine together? Again, negative 98 sine squared of theta minus 70 sine of theta plus 49. Kind of looks like a quadratic, right? But instead of x, what do we have? Sine of theta. So somebody got their quadratic formula on their calculator ready to go? Why don't you type in negative 98, negative 70, and 49 and see what you get. No, don't put sign. Just put negative 98, negative 70, and 49 into your quadratic formula. Should get 2 results. What do you got? .44. Okay, those are the 2 results I've. So instead of x equals, I've got sine of theta equals. Can somebody tell me what is the biggest value that sine can be? 1. What's the smallest it can be? Negative 1. So can sine ever be negative 1.15? No, it can't. Can sine of theta be 0.44? Is that reasonable? Yeah. Now, for the one time in this class, we've always been working in degrees or radians. Which one? Radians. Think of people who are installing gutters. Do you think they're working with degrees or radians? Degrees. And when I say people who are working, I'm not saying just those people who have those jobs. I would be working with degrees as well, right? Even though I teach math, I would be working with degrees. Radians are no fun out on the job, right? Like if you look at a square, you don't have any radian markings on there. So let's go ahead and take our calculator, and instead of working in radians, let's quick for this one time switch over to degrees, because we understand in context the problem where we're at. and I take and I inverse sine of 0.44, and I get 26.10. So if we look back at the original problem, what is that angle? It's 26.10 degrees. So if you're answering the question, how much of a bend do we make? Well, this would be the bend there, right? That's how much they would bend. So they would bend what, like 63.9, right? In order to get it to go that far. So it's not as simple as just saying, hey, we're going to say it's 45, we're going to say it's 60. It depends on the type of shape that you're making, and then that maximizes the amount of water. It's as simple as this. It's just as easy to bend the piece of tin to 60 degrees as it is to bend it to 63.9, correct? I mean, you're just bending to a certain amount. Wouldn't it be nice if somebody did the work ahead of time to say, hey, here's how you figure out your optimal bend, okay? Follow this chart. There you go. I've done all the legwork. And that way you can ensure that you're getting the most for your money in that situation. The gutter problem. What's that? Yeah, so the piece of metal comes to you like that. So we're going to bend it. So we're bending it like that. So this angle here we had is 4.1? 26.1. So that means the bend is 63.9.